Okay, we're going to discuss PBr3 or Phosphorus Tribromide. And you might have wondered why we do this instead of just using, for example, HBr or something like that. Because they both get a bromine on the molecule, right? Well, the reason we use it is to avoid carbocation formation. So your teacher may ask, make this molecule, from this alcohol, make this alkyl bromide. Well, you notice that there are 4 methyl groups on here, so that if we were to form a carbocation, we would make this molecule. And so that's what HBr does, is whenever this, if you look at the mechanism, you can go through that, you'll see that this falls off, this carbocation forms, and then we get a methyl shift over to there, and so then the carbocation ends up there, and that's where the bromine will attach. Well, that gives us a different molecule because there are 2 methyl groups here, 2 methyl groups here, whereas if your teacher said go from here to here, you would need to know to use, instead of this, you would need to know to use that, because this avoids carbocation formation. And so you end up with 3 methyl groups on this carbon and 1 methyl group on this carbon. And you can see how that works in the mechanism that we have drawn here. So we have the alcohol, this guy, and this is the PBr3. We get nucleophilic attack by the oxygen electrons on the phosphorus right here. When we do that, the bromine falls off. When the bromine falls off, we now have ourselves a good leaving group right here, and the bromine comes in and displaces this group, and we get that molecule. And this, when we're done, it looks like this. PBr, like that. And there are your electrons if you wanted to see them. And that's pretty much why we do PBr3. And thionyl chloride is the same kind of idea, where we don't want to form a carbocation, and or you have a non-tertiary alcohol that you want to get a chlorine on. You have to use thionyl chloride. And that is a different video, so you can look at that one as well.